want to work through a couple of conversion problems with you today. I understand that sometimes you may be looking at these problems going, I don't really need to write all this out because I understand that I have to multiply, I understand that I have to divide. I'm going to ask you to go ahead and work the problems using these, it's called dimensional analysis or the factor label method. I want you to go ahead and work the problems this way anyway, even if you know how to do the conversions otherwise. And the reason is because we're going to be using this particular method all the way throughout chemistry. And so if you don't understand the method, you're going to struggle a lot later on. And this is an easy way to learn the method, so that's why I want you to go ahead and use it now. So let's say, just as an example, I have a piece of ribbon that is 62.5 centimeters long, and I want to know how many inches long that piece of ribbon is. Anytime you're going to be doing a conversion, what you're always going to do is you're going to take the number that you're trying to convert and you're going to put it over 1, always. That's going to be a cardinal rule no matter what type of dimensional analysis or factor label method you're using. You're going to take what they give you and you're going to put it over 1. When you set up the next factor, what you want to do is this. Anything on the top and the bottom have to be equal to each other. He showed you in the book that when you multiply fractions by each other, you can always cancel things out, and hopefully you know that from working fractions in math before. And you should also know that anytime I multiply something by 1, I may change how it looks, but I don't change the value of it. So in this particular case, if I'm trying to convert centimeters to inches, what I want to do is I want centimeters to cancel out and I want inches to be what I end up with. So whatever I put here is going to have centimeters on the bottom. And I do know a conversion factor between centimeters and inches, so I can go ahead and put inches on the top. The conversion factor is that for every 1 inch, it is equal to 2.54 centimeters. Now this is where I tend to have students get mixed up. They'll get the centimeters in the right place, but then they tend to want to flip those numbers backwards for some reason. Keep in mind that this conversion factor has to stay just like it is. Now I can flip it over if I want. I can put centimeters on the top and inches on the bottom, but the 2.54 has to stay glued to the centimeters and the 1 has to stay glued to the inches, because that's the only way that this fraction will then be equal to 1 and I'm not changing the value of my initial number. So now I can take centimeters and I can cancel it out, and my answer is going to be left in inches. When you type this into your calculator, you're going to need 3 significant figures in your answer because you have 3 in your initial problem. And so your final answer should come up to be 24.6 inches. Notice I've got 3 significant figures, which is how many significant figures I should have. Notice I put a label on my final answer so that you know what units I'm measuring in. The next thing that I want to show you is a slight difference from the way Dr. Weil shows you to do it in your book. It doesn't matter to me which way you do it. I'm going to show you this way simply because I think it's easier. A lot of it's going to depend on how you were taught the metric system when you first learned it, probably a number of years ago. If you're not super familiar with the metric system, there are 3 specific conversions that you need to know. One is that 1 kilometer is the same as 1,000 meters. Secondly, you need to know that 1 meter is the same as 100 centimeters. And thirdly, you need to know that 1 meter is the same as 1,000 millimeters. Okay? These 3 conversions you need to commit to memory. You have to have those memorized. He tends to say that 0.01 meters is 1 centimeter, and if you want to remember it that way, it doesn't make any difference because your answers are going to come up the same. But I find it a lot easier to remember these 2 conversions than to put those decimals in them and to remember them that way. So I want to work a problem for you where I'm using these conversions in place of the ones that he tends to use as examples in your book. So let's say that I have 62.5 centimeters. I'm going to take the same number that I had up here. And this time, I want to convert it to meters. Well, if I want to convert it to meters, this is the conversion factor that I need right here, because this is the one that relates meters to centimeters. My conversion factor has to have centimeters on the bottom so that it will cancel out. I'm looking for meters, so that needs to go on the top. And remember that these numbers have to stay glued to these units, otherwise you're not going to have a fraction that's equal to 1. So I have 1 meter and I have 100 centimeters. So these two guys will cancel. Anything that's on the bottom, you're going to be dividing. If it's on the top, you would be multiplying. So when you type it into your calculator, you're going to type in 62.5 divided by 100. And so your final answer is going to be 0.625 meters. One thing that's really nice to do when you're working problems, especially if you end up having multiple steps, is that it's nice, especially for the person grading your work, if you will actually box your answer. And so I'll go up here and I'll box this answer as well, because it just makes it easier to find the answer, makes it easier for the person grading your paper, makes it easier for you when you're going back to check something as well. Let's say that I have a multiple conversion. Let's say that I have an object that's 1.25 meters long, and what I want to know is how many inches is that? I don't know of anything that is directly going to take me from meters to inches. So I'm going to have to use two different conversion factors. I'm going to still start with what they gave me, just like always, 1.25 meters, and I put it over 1. I always do it that way, okay? Whatever I multiply next is going to have meters on the bottom so that I can get rid of meters and convert it to something else. Again, I don't have anything that's going to convert me directly to inches, but I do know that if I know centimeters, I can convert it to inches because I use that conversion factor up here. So my best bet is going to be I'm going to take meters and convert it to centimeters first, and then I'll be able to convert it to inches. So I'm going to take 1 meter goes to 100 centimeters. Now notice, this is the same conversion factor I used up here, but this time I flipped it upside down because I started with something else. So my meters is going to cancel out. Now, if you prefer, you can do this in 2 steps, or you can combine it all in 1 step, and it doesn't make any difference because you're going to end up with the same answer either way. So now I need to get from centimeters to inches. So centimeters will have to go on the bottom, inches will have to go on the top, and I already know this conversion factor from before. I know that 1 inch is the same as 2.54 centimeters, and now centimeters will cancel out. Again, if that confuses you to string it all together, you can do this step and get your answer in centimeters, and then you can take that answer and then do this step, or you can string it all together and it won't make any difference in your answer either way. So when you get to the end, you notice that everything else is canceled out. My answer is going to be in inches. So I'm going to, when you type this into your calculator, you're going to go 1.25 times 100 divided by 2.54. So if it's on the top, you multiply. If it's on the bottom, you divide. And your final answer should come up 49.2 inches. I need 3 significant figures because I had 3 here. And so conversion factors don't count when you're doing conversions as far as significant figures goes. So however many I have in the beginning is how many I'm going to have in the end. So my final answer is 49.2 inches. If you struggle with these conversions, again, make sure that you ask for help because it's crucial that you understand how to use this procedure as you go through chemistry.